In June 2024, Nvidia briefly became the most valuable publicly traded company on Earth. Most people assumed it wouldn't last. It lasted, and then some. Today, Nvidia is worth $5 trillion, more than Apple, more than Microsoft and Amazon combined. It is right now, not historically, not briefly, the most valuable company in the history of human commerce. The first company ever to reach $5 trillion in market cap, and almost everyone trying to explain how this happened says the same boring thing. They make AI chips. Everyone needs the chips. Stock goes up. That story is wrong. Not slightly wrong, completely wrong. Because if chips were really the reason, Nvidia would already be in trouble. AMD makes chips. Intel makes chips. Google makes its own chips. So does Amazon. So does Microsoft. So does Meta. There is a small army of multi-billion-dollar competitors, plus about a dozen well-funded startups, all building hardware specifically designed to dethrone Nvidia. None of them have done it. Not one. And the gap, somehow, is getting bigger. So how does that happen? How does a company that in 2008 nearly went bankrupt and again in 2018 after the crypto crash lost half its market value in months end up running the most important industry on Earth with margins of 75% with a near monopoly nobody can crack? The answer is one of the strangest, longest, and most patient bets in the history of business. And it has very little to do with the chips. Jensen's real story, let me take you back to 2007. Nvidia at this point is a graphics card company. They sell hardware to video gamers. The business works, but Wall Street isn't impressed. Their CEO, a Taiwanese-American engineer named Jensen Huang, has a habit of telling his employees the company is always 30 days from going out of business. He says it so often, it becomes a kind of joke inside Nvidia. It is, by all accounts, only half a joke. Jensen was born in Taiwan in 1963. His parents sent him to the United States at age 9, not to a comfortable suburb, but to a boarding school in Kentucky that turned out to be a reform school. He cleaned bathrooms to earn pocket money. He was 9 years old. He survived it. Moved to Oregon, graduated high school, got an electrical engineering degree from Oregon State, then a master's from Stanford. By 1993, he co-founded Nvidia with two colleagues. Their first serious funding came from a chance meeting with Andy Grove, the CEO of Intel, at a Denny's in San Jose. That is not a metaphor. It was literally a Denny's. Their first major product had a fatal flaw. A competitor called 3DFX was eating them alive, but they survived. By the early 2000s, Nvidia had won the gaming graphics market, and Jensen, being Jensen, immediately started worrying about what came next. And in 2007, Jensen does something that on paper makes no financial sense. He launches a software platform called CUDA. The idea? Every Nvidia chip, including the cheap ones bought by teenagers to play video games, will support a new way for developers to use graphics cards to do math that has nothing to do with graphics. Scientific simulations, engineering problems, financial modeling. Almost nobody asks for this. Wall Street analysts openly complain. Customers don't care. Engineers inside Nvidia quietly wonder if they're betting the business on a market that doesn't exist. For the next several years, they are basically right. CUDA loses money, or more accurately, costs an enormous amount to maintain for a customer base that mostly consists of academic researchers and a handful of hedge funds. Nvidia keeps pouring resources into it anyway, quarter after quarter, while everybody else moves on. Here's the thing about a graphics chip that most people don't know. To render a video game, it has to do millions of simple calculations, simultaneously the color of every pixel, the angle of every shadow, the position of every object on screen, all at the same time, every frame. A regular computer chip does one complicated thing after another, very fast. A graphics chip does thousands of simple things at exactly the same moment. Completely different architecture, completely different strength. And in 2012, at a lab at the University of Toronto, 3 researchers, including a name you may know, Ilya Sutskever, who later co-founded OpenAI and became the center of one of the strangest corporate implosions in Silicon Valley history, trained a neural network called AlexNet. It changed the entire field of artificial intelligence overnight, and the only reason their tiny academic budget could afford the compute to train it was that they ran it on cheap Nvidia gaming GPUs. Using CUDA, that single project lit the fuse. Within a few years, every serious AI researcher on Earth was building their work on top of Nvidia's software. Not because CUDA was the only option, because it was the only option that had been carefully built and polished for years while nobody was paying attention. By 2020, every major AI framework, PyTorch, TensorFlow, JAX, was built CUDA first. Every PhD student learned CUDA. Every research paper assumed CUDA. Nvidia claims over 4 million developers are trained on the platform, and those people don't work for Nvidia. They work everywhere. At every AI lab, at every startup, at every Fortune 500 company building AI tools. This is the part most people miss. Nvidia did not just build a product. They quietly trained an entire generation of engineers to think in their language. Think about it this way. Imagine every construction company in the world spent 15 years learning to build with one specific type of crane. Not because anyone forced them, just because it was the best crane available and it was free to use. Every architect started designing buildings assuming that a crane exists. Every engineer trained on it. Every safety regulation was written around it. Now someone shows up with a better crane. Cheaper, faster, more efficient, and almost nobody switches. Because switching the crane doesn't just mean buying new equipment. It means reteaching every building plan, retraining every worker, rewriting every safety code, rebuilding 15 years of accumulated knowledge and habit, all of which was built around the old crane. That's CUDA, not a chip, a software platform that an entire generation of researchers built their careers around. Software ecosystems compound the longer they sit there. Every year, more code gets written for them. Every year, the cost of leaving gets higher. AMD's answer to CUDA is called ROCm. It exists. It works. It is also, by almost every account, years behind. Not because AMD is bad at chips, they are excellent at chips, but because you cannot catch up to nearly 2 decades of ecosystem development by hiring more engineers. The chip was never really the product. The years of habits built around the chip that was the product. Around 2019, Jensen made another move that looked overpriced and strange at the time. He spent nearly $7 billion buying a company called Mellanox, a maker of networking equipment, specifically the cables and switches that let thousands of chips talk to each other inside a data center. Modern AI is not run on individual chips. It runs on enormous clusters of chips, all stitched together, all communicating constantly. Whoever owns that networking layer owns the economics of the entire data center. Nvidia now sells the chip-to-chip connector, the cluster-level networking, the hardware system designs, the software platform, and the libraries on top. They have built a vertically integrated AI factory and made themselves the only supplier of every important part of it. The numbers that followed are almost embarrassing. Data center revenue went from around $15 billion in 2022 to $194 billion in fiscal year 2026. Total annual revenue hit $216 billion, up 65% in a single year. The most recent quarter alone was $68 billion. For context, that's more than Disney makes in an entire year, in a single quarter. And here's the number that really matters: the profit margin. Nvidia keeps 75 cents of every dollar it brings in. Apple, one of the most profitable consumer companies ever built, keeps around 25 cents. Nvidia's margins are 3 times Apple's. In a business selling physical hardware, numbers like that do not happen in a competitive market. They happen when customers have no realistic alternative. The customers have no leverage. When Google, Microsoft, Amazon, and Meta all desperately need the same product and there's only one serious supplier, the supplier sets the price. Jensen sets the price. It keeps going up. They keep paying it because falling behind in the AI race costs more than the chips do. Normally, this is where the story turns into a victory lap. It isn't, because Nvidia has real vulnerabilities, and the most dangerous one isn't technical. The first risk is geopolitics. A significant chunk of Nvidia's revenue used to come from China. Then, the US government started restricting which chips Nvidia could sell there to prevent China from using advanced hardware to train military AI. Nvidia took a $4.5 billion charge in a single quarter because of unsellable inventory. It built a China-specific chip designed to stay within the rules. The government banned that one too. This is an ongoing war between two governments being fought partially on Nvidia's balance sheet, and Nvidia has no control over it. The second risk is what DeepSeek proved. In early 2025, a Chinese lab released an AI model that matched the best American models using far fewer chips, far more efficiently, for a fraction of the cost. Nvidia's stock dropped nearly 17% in a single day, wiping close to $600 billion in market value overnight. The fear was simple. If you need fewer chips to train great AI, you need fewer Nvidia chips. The third risk is history. In 1999, Cisco made the routers that powered the internet. Everyone said whoever owns internet infrastructure wins forever. Cisco hit $500 billion in market cap. Then the market realized routers were becoming a commodity. Cisco lost 80% of its value and never fully recovered. Is Nvidia the next Cisco? Or is CUDA's lock-in genuinely different, deep enough, embedded enough, that it survives even as the hardware gets cheaper and more competitive? That is the most important question in tech investing right now, and nobody has a clean answer. Step back from Nvidia for a second, because the bigger story isn't about one company, it's about a pattern that keeps repeating in every major technology wave. And once you see it, you start seeing it everywhere. Nvidia is the picks and shovels layer of the AI boom. Every AI company, whether it's Anthropic, OpenAI, Google DeepMind, or a startup nobody has heard of, yet needs to train its models somewhere. Almost all of them train on Nvidia. It doesn't matter who wins the model race. It doesn't matter which AI assistant ends up on your phone. Every one of those companies is renting Nvidia's infrastructure to build the thing you're using. That's the business. Not winning the AI race. Owning the track the race is run on. The deepest moats in tech are almost never the thing you can see. Microsoft's moat was never Windows. It was the developers writing software on top of it. Apple's moat is not the iPhone, it's a billion users locked into an ecosystem. Amazon's moat is not the website, it's the warehouse infrastructure behind it. Nvidia's moat is not the chip, it's the quiet, nearly 20-year-old software platform that an entire generation of engineers was trained on without ever really choosing to be. In 1993, Jensen Huang sat down at a Denny's with $30,000 and an idea about video game graphics. Nobody in that building was thinking about AI. But 14 years later, he made a quieter bet. Not on chips, on habits. Build a free tool, make it good enough, keep improving it long enough, and an entire generation of engineers will build their careers around it. Their students will too. The frameworks will be written for it, the companies will be founded on top of it, and then when that technology suddenly becomes the most important race in the world, you don't need to win the race. You already built the road. That's why AMD can't beat Nvidia. That's why Google can't with its own chips. That's why 100 well-funded startups can't. Not because the hardware is untouchable, but because beating Nvidia means convincing an entire industry to rebuild nearly 2 decades of work from scratch. You can copy a chip in 18 months. You cannot copy 2 decades of habit. Nobody is going to do that. The lock-in isn't in the silicon. It's in every researcher who learned to think in CUDA. And that's not a hardware problem anyone can solve. $5 trillion. The most valuable company on Earth, built not on the best chip, but on the best bet about human habit. That's why no one can beat Nvidia.